What's up, everybody? This is Tech G back with another video to help you successfully pass the CompTIA A+ 1201 certification exam. So let's get into it. When you're working in IT support, one of the most challenging but essential tasks is troubleshooting hardware, particularly that of storage devices. The hard drives and RAID arrays, they are the backbone of many systems, storing everything from operating systems to crucial data. However, these storage systems are prone to a variety of issues that can disrupt the functioning of your network or a user's data. So in this video, we're going to dive deep into how to troubleshoot hard drive and RAID issues, covering common symptoms, tools, and techniques that will help you identify and resolve problems swiftly and effectively. So let's walk through a few key scenarios and get you comfortable with diagnosing common storage issues. All right, so let's start off with talking about LED status indicators. So most modern storage systems, particularly hard drives and RAID arrays, they have status indicators in the form of LEDs. And these little lights are like the traffic signals of your storage device. They give you a lot of useful information with just a glance. So here's how to read them. If you see a green LED, this generally indicates that the drive is operating normally, everything's good, and your data should be safe. If you see an amber or yellow LED, this could indicate warnings or minor issues with the drive. It might be experiencing minor issues like a slow read or write process. Now, if you see a red LED, this usually signals a critical error. And this could be a failing drive or an issue in your RAID array, such as a failed disk. So it is important to know what each LED color means for your devices, and you always want to make sure to check the manufacturer's manual, as some devices might have specific codes or sequences to indicate different types of problems. Another issue is grinding noises. So hearing grinding noises coming from the hard disk drive, this is one of the most telling signs of impending failure. And when it comes to hard disk drives, they contain mechanical parts that over time wear down or get misaligned, causing them to make grinding or clicking noises. So if this is happening, you want to stop using the drive immediately to prevent further damage. You want to back up any data if possible and replace the drive. And also grinding noises, this can often signal damage to the read and write heads or the spindle motor, which are both critical components that once damaged can result in permanent data loss. And then you have clicking sounds. So clicking sounds, these are another sign of a mechanical failure in a hard drive. And these noises can indicate that the read-write heads are having trouble finding the correct spot on the disk, or that there's an issue with the actuator arm. So if you're hearing clicking noises, the drive is likely in what they call a death state, or it's only a matter of time before it completely fails. And once again, if this is the case, you want to back up your data immediately if you can, as continued usage, this could result in unrecoverable data loss. All right, so another issue is that of the bootable device is not found. So if the system cannot find the bootable device, this is an indication that something is wrong with the drive or the RAID configuration. And this could be due to corruption of the operating system on the boot drive, a failed hard drive in the RAID array, or a misconfigured BIOS or UEFI setting that no longer points to the correct boot device. And then you have data loss or corruption. So one of the most distressing symptoms is data loss or corruption. And this can occur due to issues with the drive or RAID array, such as a sudden power loss, physical damage, or problems with the RAID configurations. Now, you might encounter issues like this if you're dealing with inaccessible files where the data may appear in the file system, but be inaccessible due to file system corruption. Also, you might be dealing with corrupted files like documents, images, and other files where they might open with gibberish or they fail to open entirely, or you're just dealing with some error messages where you may see errors like drive not found, file system errors, or even data integrity check failed. Now, in the event of data corruption or loss, using data recovery tools and trying to rebuild a RAID array if applicable, this is crucial to minimize downtime and avoid further data loss. All right, so let's go ahead and talk about troubleshooting RAID issues. So RAID systems, these are used to combine multiple physical drives into a single logical unit, offering improved performance or redundancy. However, when something goes wrong with RAID, it can be trickier to troubleshoot. So let's go over some common RAID-related problems and how to handle them. The first is RAID failure. So RAID failure, this can happen in several ways, and it's important to quickly diagnose the cause to prevent data loss. So here are some common failure modes. You got one drive, it fails in a RAID 1 array. And remember, RAID 1, this is a mirrored array. So this should not cause data loss since the data is duplicated across both drives. However, you should replace the failed drive as soon as possible to ensure redundancy is restored. And then you might experience multiple drive fails in a RAID 5 or RAID 6 array. This is much more serious serious. So in RAID 5, if 2 drives fail, then you risk losing all data. RAID 6 arrays, they can tolerate 2 failed drives, but they will become vulnerable if a third one fails. Now, in the event of a RAID failure, you want to try the following. You want to check for drive errors. So look for any LED status indicators or unusual noises to identify the failing drives, and then rebuild the array. So if a single drive has failed, you may be able to replace it and rebuild the RAID array without losing any data. Another issue is that of smart failure. Now, SMART, this stands for self-monitoring analysis and reporting technology. And this is a built-in feature that tracks the health of a hard drive and warns you when it detects potential problems. And common SMART failure signs include the following, such as high temperature readings. So if a drive is operating too hot, it's more than likely going to fail. You also have increased read-write errors. So if the drive is having trouble reading or writing data, it could be an indication that it is on the verge of failure. Then there are bad sectors, and these are areas on the disk that have been marked as unreadable. So if smart failure occurs, it's critical to replace the drive as soon as possible to prevent catastrophic data loss. So you want to back up all your data and consider running diagnostic software to retrieve as much information as possible. All right, so another issue is extended read and write times. So slower than usual read and write times, this can indicate several issues, such as bad sectors on the desk leading to delays, RAID array degradation, where one or more disks are underperforming. And then you have overworked disk or RAID controllers. So if the system's resources are exhausted, this can lead to slower operations across the array. So you want to check the drive's health using disk management tools or smart diagnostics to determine whether the drive is simply old or experiencing deeper issues. Another issue is low performance IOPS, and this stands for input output operations per second. And this is a metric that indicates how fast your storage can process data. So low performance IOPS, this can result from several issues. The first is a RAID array degradation, and this is a failed or underperforming disk that can lower the overall IOPS. You have fragmented file systems, and this tends to happen with traditional hard drives. So file fragmentation, this can significantly slow down read and write operations. And then you have a saturated network. So for network attached storage or storage area network systems, a saturated network connection, this can bottleneck IOPS. And to fix a low IOPS, you can check your RAID health. So look for failed or degraded disks in the array, and then consider upgrading your hardware. So if the drives are old or the RAID controller is outdated, replacing them, this can significantly improve your performance. You also have missing drives in the operating system. So a missing drive in the operating system, this usually occurs when the drive is disconnected or not properly seated, or the drive is not formatted and has bad sectors, or there are array configuration errors that prevent the operating system from detecting the array correctly. And to solve this, you want to start by checking physical connections. So ensure that your cables are securely attached to both the motherboard and the array. You want to inspect the RAID configuration. So use RAID management software to ensure the drive is included in the array. Then you want to run a disk check. So if the drive is present but is not recognized by the operating system, try running a disk check tool to resolve any potential issues. All right, so let's go ahead and wrap this up. So troubleshooting drive and RAID issues, this can be complex, but by understanding common symptoms and following a logical process, you can quickly identify and resolve most problems. So whether you're dealing with physical symptoms like grinding noises or technical errors like RAID failure, knowing how to read status indicators, check system logs, and using diagnostic tools, this will be key to ensuring you keep your systems running smoothly. And if you encounter a more serious issue that requires recovery or rebuilding RAID arrays, it's always important to have a backup strategy in place. Remember, proactive maintenance and monitoring, this can prevent many of these issues from escalating into full-blown failures. By mastering these troubleshooting techniques, you'll be able to maintain your system's performance and prevent major disruptions in your organization. All right, so with all that being said, let's do some check on learning. So our first question is, what does a red LED status indicator on a hard drive typically indicate? Is it the drive has a critical error? Is it the drive is operating normally? Is it the drive is experiencing a minor issue? Or is it the drive is being accessed? And the correct answer is the drive has a critical error. So a red LED status indicator typically signals a critical error, and this could indicate a failing drive or a problem with the RAID array, such as a disk failure or a RAID degradation issue. If a red light appears, it's essential to investigate the drive's health and back up any important data before it becomes completely inaccessible. Next question. What should you do if you hear grinding noises coming from a hard drive? Should you ignore it and continue using the drive? Should you back up your data immediately and replace the drive? Should you run a disk check to fix the problem? Or should you restart the system to see if the noise stops? And the correct answer is you're going to want to back up your data immediately and replace the drive. So grinding noises from a hard drive typically indicate that mechanical parts such as the read and write heads or the spindle motor are malfunctioning. And continuing to use the drive, this can result in permanent data loss. So the best course of action is to back up any accessible data and replace the failing drive as soon as possible to prevent further issues. And the final question is, which of the following could be a cause of low IOPS or input-output operations per second? Is it the RAID array is operating normally? Is it the drive has been properly optimized and defragmented? Is it a degraded RAID array or a failed disk? Or is it the system's RAM is sufficient? And the correct answer is a degraded RAID array or failed disk. So low IOPS, this often results from degraded RAID arrays or a failed disk within the array. And when one or more disks in the RAID setup are underperforming or failing, it significantly reduces the overall performance of the system. So monitoring RAID health and checking for degraded disks, this is crucial in diagnosing performance issues that are related to IOPS.